Why did you want to be an astronaut?
That's a good question because I don't know exactly the reason why. It is something that I got in my head when I was a kid, and I honestly don't know where it came from. If it was something I saw or something I heard, I'm not sure. But I was very young, and I decided that that's what I wanted to do. So it's so hard to answer that because all I know is it was in my mind for a really long time.
Well, let me get you to tell us a little bit of that story. Maybe it'll leak out of the side of the story. Tell us about your hometown and what it was like for you growing up there.
I grew up in west central Minnesota. My actual hometown is very small. The population, I can't even say right now, probably it's less than 100 for sure, but I don't know how many people, and not 100,000, 100 people. And my high school was in a neighboring town, Henning, Minnesota, and I grew up in Vining. So a very, very small community. And of course, anybody that's lived in a small community, everybody knows everybody. But I think one of the best things about the small community is a school that size was great for me. I had a lot of opportunities to be involved in absolutely everything. And even though my education required that when I got to college I had to go back a little further than some of my classmates because my small school, we didn't have all of those classes offered. I think the fact that I got to participate in all of the sports and all of the music and everything else that I wanted to counteracted that. And it made me a more well-rounded person, I think.
Is it a farming area?
Yes.
Mm-hmm. So you grew up on a farm?
No, we grew up, my house is on the country. We're on a lake, actually. It's the Central Lakes region of Minnesota. And, but there are farms all over the place. And, yeah.
And you left there and went not too far away to go to college. Take me on the trip with you to your college and your professional career after that that ultimately led you here.
Right. I chose to go to the University of North Dakota, which is in Grand Forks. And my sister had gone there, and I think she kind of convinced me that was the place to go. And when I started there, I actually wasn't sure exactly what I wanted to study. I had an idea about engineering, but I don't think I knew enough about engineering to know that that's what I wanted. And of course, at this time, I knew that astronaut was my ultimate goal. And so I got to the University of North Dakota, and I believe the end of my first year, I chose engineering and chose to study mechanical engineering. And so that's what I did. And during my undergraduate days, I've learned about the co-op program, cooperative education program, and I saw a sign on a wall that somebody was giving a presentation who had worked at the Johnson Space Center. And of course my eyes went like that. I'm like, you can work down at the Johnson Space Center as a student. And so I hightailed it to the cooperative education office and said, is there any way I can get a job at the NASA Johnson Space Center? And so I filled out the application, and they ask you to list your top 3 places you would like to work. And I put NASA Johnson Space Center, and I didn't have a number 2 and 3. I was like, well, that's where I want to work. And I got very fortunate, and I did get the job as the co-op student. So I spent quite a few semesters down here in Houston when I was a student, and that was invaluable. I think it extended my graduation by a while, but I think it was very valuable.
What areas here were you working in?
My first co-op tour, I was in the robotics ER, and then I moved over to MOD for 1 semester, and then after that, crew and thermal systems, and that's where I ended up staying. And when I finished graduate school, that's where I was hired. So.
Go ahead.
And when I finished at UND, then I decided, there was, of course, everybody makes the decision: do you continue in school or do you start work? And I didn't feel quite done yet, and so I decided to continue on graduate school, and chose the University of Texas at Austin, and had a spectacular advisor there who I went to see. He was at the time the head of the mechanical and engineering department, Ken Diller, and he just made me feel really good about going there, and I chose to go there, and he ended up being my advisor. And we talked a lot about the research I would do. He helped me get a grant from NASA to do my research, and I was able to finish my master's and my PhD in 4 years with his help, and it was fantastic. He was not one of those advisors that tries to keep their students there as long as they can to get the free work. But so then when I finished my PhD, I got a full-time job offer from NASA, and so I worked in the Crew and Thermal Systems Division. And I applied for the astronaut program the next summer, I believe, is when applications were due, the summer after I graduated with my PhD. And I never thought that I would actually be selected. I thought, it's time, I have my PhD now, I'll put in my application. But luckily, for some reason, I was selected, and so that's where I am today.
And you were, if I understand right, you were still working at the Johnson Space Center while you were doing your graduate work at the University of Texas.
Yes, I maintained the cooperative education program through that entire time. So I worked summers, I think probably 2 summers while I was in graduate school. I came back here to Houston and worked.
With the idea of being an astronaut all along, even from when you were a little girl.
Yes.
You are one of only a little over 200 different human beings who have ever been on board the International Space Station. From that perspective, what do you hope in this case, this mission, that you'll be able to do that will help inspire other little girls and boys to want to be explorers?
I hope they see from, looking at my situation, that there are possibilities out there. I think some children don't know the possibilities, and I think some children may not know what they're capable of. And I'm hoping that, especially a lot of people from small towns, you get kind of stuck. And it's not that it's bad being in a small town, that's fantastic. But if you have a dream of doing something different, by all means, there's probably an opportunity to do it if you really want to, and you really want to set your mind to it. And I set my mind to it when I was a kid, and it worked. And there are definitely possibilities of disappointments along the way, but that's part of life, and you pick yourself up and you just keep going, and hopefully that hopefully children will see me and the other people who are doing this, and not just the people that are the lucky ones like me who actually get to fly in space, but the other people working here. There's some incredible work that happens at NASA, and I think it should be any child's dream to be able to help with a program like this.
As an astronaut, when you fly in space, you take some risks that a lot of the other people who work for NASA don't take, not personally anyway. Since you're doing it, I'm going to assume that you think that the results of that work are worth the risks. Why? What is it that you think we're getting as a result of flying people in space that makes it worth taking those risks?
I think a lot of it is based just on human nature, that we are all very curious people. Human beings like challenges, and this is an ultimate challenge. A lot of it also has to do with, it's an exciting thing, and we talked about children, and children and adults alike look at spaceflight and it's interesting and exciting, and if it can get the kid in school to study his or her science a little harder or math a little harder, I think that's an important thing, and our country needs people in the sciences and the maths and the technology to be our leaders in the future. And so I think if it does that for an education purpose, I think that almost in and of itself is a good reason to do it.
You and your crewmates are next in line to launch to the International Space Station. Karen, tell me in summary, what is the goal of your mission, and what are your jobs going to be on this crew?
Well, obviously we've been building the space station for about 15 years, so that has always been our primary task, to get it built. Well, right now we're at a point where we actually can use it for what it's intended to be used for, and that's as a science laboratory. So the main goals for all of the increments now is to use the station as the science laboratory that it is. So that's mainly what we'll be doing, along with upkeeping, like you would in your house, keeping it up and running. Myself, all of us are pretty much trained on the same tasks these days, and we're prepared to do anything. Some of us are specialists in one module, maybe not another. I'll be flying with an ESA astronaut, so the Columbus module will be his. He'll be the specialist there, and I'll be the specialist in the Japanese module. And when we hand over about a little over halfway through the mission, when Chris Cassidy and their crew leaves, I will become the USOS lead. My Soyuz commander, Fyodor, will become the commander. But since he's on the Russian segment and knows more about the Russian systems and I have a better understanding of the U.S. systems, I'll become the U.S. OS lead at that time.
You've been to the station once before, but it's different now. What are you looking forward to about seeing on this trip?
Well, when I launched the first time, we took the Japanese module, and there's been a lot that has been added since then. The exposed facility on the GEM is there now, and the Node 3, where we have all of our exercise equipment. And of course, I think probably what everybody would say, the cupola. It's our window to the Earth, and I can't wait to see that. I'm sure it will take my breath away, even though I've seen the Earth from that distance before. I'm really excited to use that window. And also, the shuttle flights are so quick. 14 days I was on orbit, that you never really get to, I guess, stop and smell the roses, really. And so I'm looking forward to that aspect of it, to live there and just become a part of that environment.
You pointed out a minute ago that the main goal of everything on the space station right now is the science research. Of course, you've got to take care of the station as well. How would you convey to people the potential for what we can learn in science on board this space station?
Actually, I think there's more than just science that we're learning from space station. It's multifaceted, really. Even during the building process, we were learning things about hardware and equipment that, we have to build this closed system where we can't always be bringing up water. So we've had to design in systems to recycle liquids. And that has obvious, definite potential for Earth operations. And just learning how to build, learning how to use the robotics. We've been learning this whole time, and a lot of that has applications to things that we're doing on the Earth. Another aspect, just looking at STS-124, we flew in an American space shuttle. We carried with us a Japanese laboratory. We used a Canadian arm, robotic arm, to install it to a module that was built in Italy. And we did all this traveling 17,000 miles an hour over that. These modules never having been mated on Earth to see if they fit. And it's that international aspect of it that I think we have learned a lot, and I think a lot of other organizations could look at that and learn as well, and just people on Earth learning what we've done internationally. And then, of course, the science. That's going to be the big thing from now on. Without the laboratory as it is without gravity is obviously an extremely unique environment, and there are a lot of opportunities to test various processes and look at the intricacies of various processes without the effects of gravity. And there's a lot of potential for Earth applications.
We're going to talk about some of those specifically here in a minute.
Mm-hmm.
Of course, one of the big areas of the intention of this research is to find out how being in that environment affects people, and what can be done to counteract the negative effects of how that affects people. Recently, the program decided they're going to send a crew up there for a full year to try to gain some more knowledge in that area. What do you think about that idea of a mission that's going to be twice as long as yours?
Well, I think it's a natural evolution, especially if we're going to start traveling further away and missions become longer. We need to start looking at if a mission longer than 6 months will have different effects or more effects on the person. So I think it's something that it was about to happen at some point, and we have this laboratory up there that is the perfect place to try it out. So I think it's great.
Would you like to try it out for a year yourself?
That's really a tough question, because if you look at just the technical aspect of it, and I would love to live there. I would love to be involved in the science. I would love to be the guinea pig for all of that. But if you look at personal, where I am in my life right now with my family, I don't think I would want to spend a year away right now. So, maybe if you asked me at another time, but right now I don't think I would actually want to.
Now, you've been to the space station, and you've felt the effects of what being in that environment for even 2 weeks, in your case, can have on somebody. What areas should we be working on to maximize our chances for sending people on long duration missions further away?
Well, obviously, probably one of the most important things, at least from the crew member's perspective, is crew health. And so we need to look at all of the things that radiation and lack of gravity do to us and make sure that we can mitigate that, all the negative effects as much as possible. But there's also hardware effects. We need to make sure that the equipment can be maintained without spares that we haven't thought about. And then also, I think we probably need to get some sort of crew autonomy built in.